Okay, folks, looks like quiz is timed out. So let's go ahead and get started with today's material then. So again, building on what we were doing in the video where we introduced oxidation reduction reactions or redox reactions. Okay, so the main thing there, and you saw it in the quiz, is I wanted you to be able to essentially identify a redox reaction when you see one and maybe identify what's being oxidized or reduced based on those definitions that you had in the video. Now, as far as today goes, we want to go a step further with this. What we want to start to learn to do now is to balance redox reactions. Now, I mentioned to you last time that balancing a redox reaction is a totally different method from the normal balancing of reaction equations that we've done up to this point. Normally, we do it, as we say, by inspection. So we can sort of look and see how many atoms of each element are on either side of the arrow, and we balance them out with those whole number coefficients. So we're doing something similar here, but there's just a little bit different way of doing it. So it's like anything else we do in chemistry. There's actually a rhyme and a reason for it. There's a process or a prescription that we use. Okay, so the trick is going through stepwise and learning that prescription. Now we start out by looking at individual half reactions. Now remember from the video that a redox reaction is actually made up of two half reactions. You got an oxidation half reaction and you got a reduction half reaction. And then in the end, what you can do is add those two half reactions together to get the overall redox reaction. So as far as balancing goes, rather than trying to show you everything right up front, I like to break it down into bite-sized pieces. So when we do this, the first thing that we have to learn is to balance the individual half reactions. And so when we have those, we can then add them back together to get the whole balanced redox reaction. So let's start by learning the rules for balancing half reactions. Now, another thing that we have to think about when we do this is we have to define whether we're an acidic or basic solution, okay? Now, as far as balancing half reactions goes, we're only going to do them in acid. I know Chem 101 has some problems and such where you can do half reactions in base, but I like to do them in acid. And then when we add the half reactions back together to get the overall redox reaction, then I like to adjust for the fact that we're in base solution. So we're going to do everything in acid at this point. Okay, keep it simple. All right, so what I've given you here is an example of a half reaction. So this is this little reaction that you see here where you've got SO32 minus going to S2032 minus. So basically two polyatomic ions there. All right. So what I'm going to do here is take you through the process step by step. So I have each step written out, and then under each step, I've got some space here. So what I'm going to do is I'm going to write out the half reaction there. So let me just sort of write it as I have it here. SO32 minus aqueous. And a lot of times what I'll do as I get into this is I'll drop the AQs because the assumption is, unless you see a solid liquid or a gas there, the assumption is that you're an aqueous solution. So there's so much stuff that actually happens here. I'll actually start dropping that at some point, but be careful. Chem 101 wants to see it. So don't forget that it's there. But for now, I'll leave it in just since we're getting used to this. Okay, so there's the half reaction as I wrote it. So step number one here is to balance all non-hydrogen oxygen atoms by inspection. That means do it the normal way. So I got oxygens in there, right? And I'm going to leave those alone for now. But I have sulfurs. Sulfurs are non-hydrogen oxygen atoms, and I'm going to do that the regular way. So you'll see that you have one sulfur on the left, two sulfurs on the right. So we're going to adjust by putting a coefficient 2 in front of the sulfite ion there. Okay, so that balances the sulfurs. But now you're going to notice the oxygens are out of whack. All right, so that brings us to step number 2. We want to balance oxygens by adding water to the oxygen deficient side. Okay, so it seems like a weird thing to do, but it makes sense when you get into it. So let's write what we got now. 2SO32 minus. I'm just going to start leaving those AQs out because lots of stuff's going to start to happen here. And I'm going to S2O32 minus. Okay, sulfurs are okay, but now we got to take care of the oxygens. All right, so what you're going to notice is I've got 2 times 3 or 6 oxygens on the left, but I only got 3 oxygens on the right. Okay, so I'm oxygen deficient on the right-hand side. So what I'm going to do is I'm going to add enough water molecules to make the oxygens work. And I'm going to add them to the right-hand side because that's where I'm deficient. Okay, so how many waters do I need to add to the right-hand side, guys?
3.
3, you got it. Very good. Okay, and I will put an L there because water is a liquid. Okay, it's not in the aqueous state. All right, so now it looks like we're good. Now, you'll notice how that the hydrogens are out of whack, right? Because I got 6 hydrogens over on the right-hand side, but I got no hydrogens over on the left-hand side. So I got to account for that. So that's step number 3. Okay, so step number 3 says that we're going to balance the hydrogens out by adding hydrogen ion to the hydrogen deficient side. Now we can get away with this because remember, we said that the solution is acidic. So if I got acid in there, I've got hydrogen ion, right? Because remember that from the definition of an acid from the last kind of reaction we dealt with. So let's go ahead and just write the reaction as I have it. All right, and that's going to S2O3 2 minus, those are both aqueous, plus 3 waters. Leave that as a liquid there. Okay, so let's see. It looks like the left-hand side is my hydrogen deficient side. I'm going to account for that by adding hydrogen ions. How many do I need to put over there?
6.
Very good. 6 hydrogen ions, good. Now those are going to be an aqueous solution, so I'll just leave that off. All right, so now we're almost there, guys. All the elements are balanced out, okay? But there's one other thing that we have to account for, and that's actually the charge, okay? Because remember, this is a redox reaction, and what's actually changing is the charge on both sides of the equation during a redox reaction because of that transfer of electrons from one thing to another. All right, so the last thing here is to balance out the electrons or balance the charge. And we do that by tabulating the charge. That means just adding it up on each side of the arrow. And then what we're going to do is we're going to add enough electrons to the more positive side until the charge on that side balances the charge on the more negative side. We're going to make those two charges equal to one another. So that'll make sense here in just a sec. So let me just write down what I got. Just carrying down from upstairs there. And we'll tabulate some charge here in just a moment. All right. So now we're going to add up total charge on either side of the arrow, and I'll just write it above it, maybe circle it so we can kind of keep track of it. So focusing on the left-hand side, I've got 6 units of positive charge from the hydrogen ion, right? But then I've also got 2 times 2 minus, which is 4 units of negative charge, right? So what's my total charge on the left-hand side? 6 plus 4 minus, what do you get?
2 plus.
2 plus, yeah, that looks right. Okay, everybody agree with that? Everybody see that we would get 2 plus there on that side? I think that's right. Now, what's your total charge on the right-hand side? That's an easy one. There's no math involved. What's the total charge on the right-hand side? You can just look at it and see.
Is it just 2 minus?
2 minus.
Yeah, just plain old 2 minus from the S2O3 2 minus. So I'll put that there. All right, so what does the rule say? It says we're going to add electrons to the positive side until it matches the negative side. Okay, so how many electrons do I have to add to the positive side to get the same charge I have on the negative side?
4.
4, you got it, right? So it's going to be 4 electrons. Everybody see where that came from? Yep, I need to add 4 electrons there to make a 2 plus look like a 2 minus. Okay. Now, the other thing I can kind of do is I can look at this point in the game, and I can sort of assess whether this is going to be an oxidation or a reduction half reaction. And I can do that by looking at which side the electrons are on. So it's always a good habit to start to do that. Now, what you're going to notice is that the electrons are on the reactant side. They're on the left-hand side. So what that tells me is that those electrons are being gained as a reactant to give me a product. So if something gains electrons, is that oxidation or reduction?
Reduction.
Reduction. So this is actually going to be a reduction half reaction. Okay, does everybody see that? Now, if the electrons were on the other side, that means something on the left-hand side is giving them up, right? So then we would have an oxidation half reaction. But this one is a reduction because the electrons are on the left-hand side. So think about whether the electrons are a reactant or a product. That's the easiest way to do that. All right, we'll do another one of these. Yeah, go ahead. I was going to ask for questions
Can you
anyway.
go back and show me where you get that 6H?
Sure
from,
will.
so I
Yeah,
can
let's go
fully
do that.
understand this problem.
Yeah, let's do it. All right, so look at in item number 2 there, we balanced out the oxygens, right? Now, when I balanced the oxygens, I did it by adding water. Now, look what I added when I brought the water in. How many total hydrogens do you have there on the right? That's what I just under.
6.
6 of them, yeah. How many do you have on the left?
0.
0. Okay, so item number 3 says, now we balance the hydrogens, and we do it by adding hydrogen ion. Because we're in acid, we can do that to the other side, right? So that's where the 6H plus came from. I have it in there to balance out the 6 hydrogens that show up on the right.
Oh, okay. And the reason why there's 3 water is because there's 2 SO3s and 1 SO3, right? And that's why there's 3, because there's 3 in the equation.
Yeah, you got it. So if you look
Okay.
at the oxygens there, on the left-hand side, you've got 6 oxygens. On the right-hand side, you got 3 oxygens. So I had to add the 3 waters to account for the 3 extra oxygens that I would need on the right to balance the left. So that's where the waters came from. That goes back up to item number 2. Okay, so again, it's just like anything else. There's a sequential way we go through this, and we'll just review it again real quick, and we'll do another one. So again, first step is we want to balance all non-hydrogen oxygen atoms just the regular way by inspection. So that's where the 2 here came from. I'm balancing out the sulfurs. Once I got that done, then I go on to step 2. I want to balance the oxygens by adding enough water to the oxygen deficient side to make both sides equal in terms of oxygens, right? So that's, as you just said, why I needed to have the 3 waters there, because I needed those 3 extra oxygens on the right-hand side. Okay, so now my sulfurs and my oxygens are good, but my hydrogens aren't. So that's where item 3 comes into play. So now what I'm going to do is tally up the hydrogens on both sides, and I'm going to balance the hydrogens by adding hydrogen ion to the hydrogen deficient side. So I have no hydrogens on the left, but I'm going to need 6 to account for the 6 I have on the right coming in with water. And then the final step, once I've got all the elements balanced out, is to get the charge balanced out. And we do that as I showed you here. Okay, so again, it's really good to know those steps in that sequence, because if you get out of whack with that and you start doing one thing before something else, it's going to screw everything up. So it's important to go through those steps in the sequence. All right, so let's just do another one so we can get an idea again of following that sequence. I won't write out the steps this time, we'll just apply them. So here's another simple one. Let's do nitrate. I'll start out by just reminding us that it's an aqueous solution. And we got nitrate going to dinitrogen monoxide, so that's N2O. And that's a gas, it looks like. Okay, and this is going to be an acid. So that tells us we're going to use hydrogen ions to balance when we need to. Okay, so let's just kind of go through this. All right, so I start with which element?
Nitrogen.
Yeah, beautiful. So I'm going to do that by putting a 2 out front of my NO3 1 minus. Okay, and that makes sense because now that's going to balance the nitrogens out on both sides. Everybody good with that? All right, After the non-oxygen hydrogen elements, where do we go next? What's the next element we have to do?
Oxygen.
Oxygen. Okay, and we're going to look to see which is a oxygen deficient side. It looks like the right side. Do you guys agree with that? Have fewer oxygens on the right than the left. So how many, and I fix that by adding waters, right? How many waters would I need to add to the right? So count them up. I think that's right, because I've got, well, it looks like it's going to 5. So I've got 2 times 3, which is 6 oxygens on the left. Everybody see that? And I've got 1 oxygen on the right. So how many waters am I going to have to add to make them work? You're close.
5.
5, there you go. That's exactly right. Very good. It's like accounting. That's what I like to think of it as. All right, so after oxygen, where do we go next? What elements after oxygen?
Hydrogen.
Yeah, very good. So how many have we got on the right, does it look like?
Yep,
10.
10.
10. How many do I need on the left?
10.
10. And then there aren't any over there, so I might as well just add them, right? So I'm just going to put them here. Okay, I'll put my AQ down there just to be proper about it. I got to have 10 of them, right? Whoop, forgot about putting my 10 up there. Okay, so now I've got the nitrogens, oxygens, and hydrogens all balanced out, don't I? So what's the last thing we have to look at? It's charge, right? We have to look at the charge. So let's tally up our total charge on the left-hand side. So I've got 2 units of negative charge, and it looks like 10 units of positive charge. So what's my overall charge on the left? What do you guys think?
8 plus.
Yeah, that's exactly what I would say. 8 plus. Everybody see that? I think we got 8 plus over there. I would agree with that. 2 units of negative charge from the nitrate, 10 units of positive charge from the hydrogen ion. So 10 plus plus a 2 minus is an 8 plus. What's my total charge on the right-hand side?
0.
0, you got it. Okay, so which is the more positive side? Oh, that's easy. That looks like the left-hand side. So here's the last question. How many electrons do I have to add to the left-hand side to make it look like the right-hand side charge was?
8.
Yeah, very good. Sure enough. All right, so I think I have a balanced half reaction here now. So my question now is this a reduction half reaction or an oxidation half reaction?
Reduction.
Yeah, because you look at where the electrons are, right? So if the electrons are over on the left-hand side as a reactant, it's reduction. So it's the same as the one we did before. That's a reduction half reaction. Very good. All right. Now, let me see. I think I've got about 15 minutes worth of Chem 101 practice on this. Let me go check that. I'll pop over there real quick and see. And we're chapter 4, redox 1. Yep, 15 minutes. So we're going to spot on with that. So let's go ahead and get started with that. And again, ask questions along the way if you're not sure of something. But a lot of this is, again, going back to the video stuff and identifying redox reactions. And there's a couple half reactions in there to look at as well. But if something's not making sense, ask. Looks like we got, what, 5 questions to do there. All right, good. Looks like we got folks getting to some of the half reactions there now.
Can you go over number 5?
Sure, we can do it. All right, we'll just work it on the whiteboard here. How's that? So it looks like I've got H2SO3. That's sulfurous acid. I'm not going to stick states in there. Understand they're aqueous. And that's going to the sulfate ion, right? Okay, so let's start with sulfurs. Sulfurs look good, right? So I don't think I have to do anything there. After the sulfurs, I go to oxygens, don't I? So who's oxygen deficient? Oh, it looks like the left-hand side. So how many waters do I need to add there?
Just 1.
Just 1, you got it. So we'll stick it in there. Okay, so let's count up our hydrogens next. How many hydrogens do I have on the left?
Four.
I see 4. How many do we need on the right? We need 4, right? So what am I going to add?
4 hydrogens.
You got it. Okay, so let's tally charge. I think we got the sulfurs, hydrogens, and the oxygens done. So let's check our charge. Any charge on the left? I don't see any, so I'm going to put a 0 there. What's my total charge on the right?
+2.
Yeah, that's exactly what I would say. Okay, so which side do I need to add my electrons to? Always add them to the more positive side, right? How many?
It had 2.
You got it. That should do it. Let me see if that's the right answer. All right, so I get H2SO3 plus H2O going to SO4, 2 minus, 4H plus, and 2 electrons. Yep, we got it. Does that make sense?
Yep. Thank you.
Awesome, no problem. All right, guys, we're down to about a minute here, and you have a little more time to work on this, which you're welcome to do. But as far as what we're going to do on Monday, we do have a new video, and that's where we're going to kind of tie it all together and learn how to take what we learned today and actually combine balanced half reactions back into a balanced full redox reaction. So that's the video for Monday. So make sure you guys look at that and be ready for a little 5 for 5. Probably might focus on balancing half reactions is my guess. All right, guys. You guys have a wonderful weekend. Get outside if you have it. It's nice. Go run, do something fun. The sun's out, and we'll see you on Monday.
Thank you.
You're welcome. Enjoy.
Professor,
Yeah, go ahead.
I will not be able to attend class on Monday because I
Okay,
have
fair enough.
guard.
Yep, no problem. But it's just nice for me to know. But yep, no problem. Not everybody gets to everyone, so that's absolutely okay.
But I would I'm not doing the best on the quizzes, so will it be counted against me if I don't take this one?
Well, you just don't get credit for it. So you don't get, I mean, in the sense, I'm not going to like take points away from you. But if you remember back on the syllabus, there's a no makeup rule, but that's not a problem because we have an extra one for 20 points at the end. So that's where you kind of make up for a miss here and there.
Right. Okay.
All right.
All right. Yes. Thank you.
All right. Have a good weekend.